Hi, I'm Alex Kiss, and this statistics video will be on an example of the two-sample t-test. In an earlier video we went over a helpful summary table. Let's review that here. The concept behind the test is that the mean of one sample is compared to the mean of another sample. Keywords or key idea to help you identify this test are that the data follows a normal distribution and that the two samples are independent. The hypothesis form: H0, the null hypothesis, is that mu1 equals mu2, so the mean of sample 1 equals the mean of sample 2, versus the alternate hypothesis HA mu1 not equal to mu2. The test statistic is shown here. It's t equals x bar 1 minus x bar 2 divided by the square root of s squared over n1 plus s squared over n2, where s squared is a pooled variance. For our example, two groups of patients are randomly assigned to drug A or drug B in an attempt to reduce their systolic hypertension. At the end of the study, the group of 25 patients on drug A had a mean systolic blood pressure of 141.2 with a standard deviation of 18.2, whereas the group of 28 patients on drug B had a mean systolic blood pressure of 133 and a standard deviation of 15.2. The question of interest is whether one drug was more successful than the other in reducing blood pressure. Since we have two samples, those on drug A and those on drug B, we know we're looking at a two-sample test. Blood pressure is a continuous variable known to be normally distributed, so we will consider a test that applies to normally distributed data. Our two sets of data are from different samples, those on drug A and those on drug B. Therefore, they're considered independent samples. This would differ from the case in which we took, say, another set of blood pressure readings on the same group of subjects. So these two samples then would be considered dependent because they were from the same group of subjects. This is what would distinguish the paired t-test, in which you look at dependent samples, from the two-sample t-test in which we're looking at independent samples. Therefore, we know that we have two samples. The data is normally distributed. The two sets of data are from different samples and so are considered independent. We have means and standard deviations for each group, and this is going to lead us to the choice of the two-sample t-test. The hypothesis statement for this test, two-tailed hypothesis, is H0 mu A equals mu B. The mean of those on drug A equals the mean systolic blood pressure for those on drug B, versus the alternate, the two samples means are not equal, mu A not equal to mu B. Our test statistic, t equals x1 bar minus x2 bar divided by the square root of s squared over n1 plus s squared over n2. For this t statistic, we'll first need to calculate our pooled variance s squared, and that we can do from the following formula. So knowing that our sample in Group A is 25 subjects and we have a standard deviation of 18.2. Those on drug B, there are 28 patients with a standard deviation of 15.2. We place those numbers into the formula, and this gives us a pooled variance of 278.2. Therefore, we fit these values that we know, the mean of the two groups and that pooled variance, into our test statistic, and we obtain a t-value of 1.79. So we know that we have 25 patients on drug A and 28 patients on drug B. The degrees of freedom for a two-sample t-test are going to equal n1 plus n2 minus 2. So 25 plus 28 minus 2 equals 51. A t-value of 1.79 on 51 degrees of freedom corresponds to a p-value of p equals 0.08. We therefore fail to reject the null hypothesis and conclude that the two groups are not statistically different. Therefore, we do not see evidence that one drug lowers blood pressure more than the other. For further information on statistics, feel free to visit our website, check out any of our other videos, or see our Statistics Professor app.